All right, welcome to the Explainer. Today we're diving into a really critical piece of cloud architecture, the AWS NAT Gateway. Now, this is one of those services that kind of works quietly in the background, but trust me, it's absolutely essential for building secure and really robust applications. So, to really get why the NAT Gateway is so important, you have to start with this. This is a foundational concept in cloud design, famously said by Amazon's CTO. This one idea, that failure is not just possible but inevitable, it completely shapes how we build systems that can actually survive in the real world. And that leads us to this classic problem. So picture this. You've done everything right. You've locked your database or your application server away in a private network, safe from the public internet. Great. But now it's isolated. So how in the world does it get out to download critical security patches or connect to an API without you just punching a giant security hole in your wall? Well, the solution is a fundamental networking concept that I like to think of as the network's doorman. It's the key that lets you talk to the outside world while keeping that front door firmly locked and bolted. So in plain English, network address translation, or NAT, it's basically a translator. It lets a whole bunch of devices on a private network, each with their own private IP address, all share one single public IP address when they need to talk to the internet. And I love this slide because it just simplifies the whole thing perfectly. Think of that NAT device as a doorman. It handles all the outbound requests, kind of like a proxy. But here's the crucial part. It makes sure that nobody from the outside can just start a conversation or even see what's going on inside. The outside world only ever talks to the doorman. Okay, so that's the general idea of NAT. But how does AWS handle this? Well, they took this essential networking function, and they turned it into a super powerful, fully managed service that's built from the ground up for the cloud. So, the most important thing to get is this. It is a one-way street for starting conversations. Your private servers can reach out to the world, but the world cannot reach back in uninvited. This is the whole magic trick right here. This is the core security feature that solves that problem we talked about at the beginning. Before this managed service existed, you had to roll your own. You'd set up a regular server to act as a NAT instance. And this chart just brilliantly shows the trade-off. Yeah, the do-it-yourself instance is cheaper, but now you're on the hook for patching it, for scaling it, and making sure it doesn't become a single point of failure. The managed gateway, on the other hand, it costs more, but you get high availability and massive scalability right out of the box, without that operational headache. And just to give you a sense of its power, a single NAT gateway with just one IP address can handle a staggering number of connections at the same time. We are talking 55,000 concurrent connections to a single place. That is a lot of traffic. And it's built to scale way beyond that. By just adding more public IP addresses to that single gateway, you can add up to 8, you can increase its capacity 8-fold. Suddenly, you're handling almost 500,000 connections. It can handle even the most demanding workloads you can throw at it. Okay, so this thing is powerful, it's scalable, but let's go back to that Werner Vogel's quote from the beginning. Everything fails all the time. A tool this powerful can still be a huge weak link if you don't use it right. So how do we make sure our architecture is actually resilient? This right here is the classic mistake. So think of an availability zone, or AZ, as just a separate data center. If you put all your eggs in one basket, meaning you route all your traffic through one single NAT gateway in one AZ, and that data center has a problem, the whole thing goes down. Your entire application loses its connection to the outside world, even if your servers and other data centers are totally fine. So the solution, and really this is non-negotiable, it's the only way you should do this, is to put a dedicated NAT gateway in every single availability zone where you have private resources. That way, if one of them fails, it's completely isolated. It doesn't affect the others at all. This is how you build an application that truly lives up to that everything fails philosophy. All right, so we've talked a lot of theory, the what and the why. But what does this actually look like day to day? What are the real-world jobs that absolutely depend on this thing? The truth is, the use cases are everywhere. Your private servers need to reach out to download security patches. Your databases need to securely push their backups to a service like Amazon S3. Your applications need to send logs out to monitoring systems or call third-party APIs for things like payment processing. All of these essential, everyday operations are made possible and, most importantly, made secure by a NAT gateway. And that brings us to the final and, let's be honest, crucial consideration for any of us building in the cloud. How much does it cost? Managed services are convenient, but what's the real bottom line? So with AWS, you're paying for two main things. There's an hourly fee for each NAT gateway you have running, and then there's a fee for every gigabyte of data that passes through it. But it's so important to see what you're actually buying. You aren't just paying for connectivity. You're paying for managed, high availability, for automatic scaling, and for less operational work for you and your team. So really, the big takeaway here is to try and frame the cost not just as an expense, but as an investment in resilience. And that leaves us with a final question for you to think about with your own projects. When you're looking at the price of building something the right way, are you also calculating the much, much higher cost of what happens when things inevitably fail?